So you have a note taker?
Yeah.
Not yet.
Are you
And for
volunteering?
the ticker, you see now, oh, yeah,
Yeah, well,
you give it. Perfect. You know how to do it.
yeah, I'm just trying to get it to work, which is not so successful. All right, we're going to get started in a couple minutes, but first, we'll wait a minute or two for people to filter in. And I warn you, I am looking for a note taker. It's going to be a light lift because we're mostly presentations today, but I would appreciate volunteers before I have to volunteer somebody. All right, that's a lot quieter, thanks. So, any volunteers for note taking? Now that the doors are closed and you can't escape, as you can't actually start the meeting.
We have very simple notes.
So my name is Eric Vink. I'm the responsibility for this working group. We cannot start the meeting before having a note taker. Note taker is not a menu taker, right? With recording. It's only to summarize questions and action items to be done. Based on the agenda of today, except for the first point, I don't expect questions and answer or at least action items. So it may be maximum 20 lines. Any volunteers? As we select the first guy in the first row, something like that. Thank you.
Thank you so much, Alan. All right. Yeah, poor planning on my part.
But we won't mock as a result.
All right, so thank you everybody for coming. My name is Leslie Daigle. I'm co-chair of this working group, and Kyle Rose is also a co-chair, and he is present remotely. I don't know if he wants to share a cat picture at the minute. There he is. He's real. He's not an AI. Thank you, Kyle. And our technical advisor is Glenn Dean. Okay, and I have not succeeded in getting the clicker to work, so I'm going to ask Kyle to move to the next slide, please.
You took control of the slides.
Oh, did I? So I did. That makes it even easier. Uh, so this is Monday. We can still go through the note well in some detail. This is just a reminder with all the detail that by participating in the IETF, you agree to follow IETF processes and policies, which are outlined in the various documents listed here. You should uh, review this document in some detail at your leisure. And next slide, please, because I think you've taken it back, Kyle. Perfect. Thank you. So note really well, not only do we have policies around the development of our work, we also have policies around participation and code of conduct. So these are all the details that you should keep in mind um, as regards how to engage with people and how to behave yourself in the context of this public meeting. Thank you. Next slide, please. Some meeting tips. I would, at this point, ask everybody who is in the room to please make sure to join the online tool for showing your presence here. That both allows us to keep accurate count of how many people come to the meeting. And also because should you have a question or wish to get in the queue, we will be using the Meet Echo queue exclusively for taking questions. Thank you. Next slide, please. And there are resources. There are always resources. Next slide, please. So this is our agenda for this meeting. It's pretty simple. We have a minute taker or a note taker. Thank you so much, Alan Friedel. And now we can bash the agenda. This is the agenda as it has been shared publicly. We will spend some time going over our working group document. This week, there is no other IETF work that is being presented per se, but we do have a few industry updates. So any bashes to the agenda? Seeing none, thank you. We'll move on and start with the update on the network overlay impacts document. Sanjay, if you would come join us.
Good morning. Happy Monday morning. My name is Sanjay Mishra and from Verizon, and I have my co-author Glenn Dean on my left, Comcast NBC Universal, and we have an update on network overlay impacts to streaming. Next slide, please. Just a quick recap on the life of the document. So we submitted one version 2 just before this meeting last week. And so that's where we are with version 2. And between March and July, we did updates based on feedback from Jay. He submitted a PR and then a bunch of cleanup in general. So that's where we are today with version 2. Next slide, please. So network overlay, just a quick recap, as some of you might not have seen this document. So network overlays is really a function that sits on top of the native network policies and may have some role to play in terms of whether it's changes to the routing or the DNS resolvers or an IP address assignment, etc. So these are what we call as network overlay that are sitting really on top of the existing network policies. And they have, for various reasons, they exist in the network, but some of these may also have unintended consequences, particularly to the streaming workflow, and that's what this document tries to capture. Next slide, please. So to give a little bit more concrete example of what the network overlay policies are and what might they impact to the underlying native network. So imagine changing in the routing, and that might basically end up changing either the egress or the ingress or the egress path, and that might then affect the delivery of the streaming service. Similarly, changes to, and this could also be done by the routing change can also happen because of the protocol or application specific changes that might cause different paths to take different route in the network, and that might affect the overall latency, etc. Likewise, DNS changes can also have unintended consequences, and we have seen some in our streaming delivery where the native DNS resolver relied on using eDNS 0 field with the IP subnet of the end user client, and using an external DNS, you lose that ability. And when you lose that ability, then you lose the ability to deliver as intended, and that adds latency. So it's not good for the end user as well as the streaming service that is charging the customer for that service. Likewise, the IP address assignment also have impacts to the streaming in general, or even your app. For example, Fios TV app has a strict relationship with content publishers as to what you can view at home versus what you can view when you're out of home. Certain channels are not available to viewing outside. So you might be home and you might not be able to watch streaming content that you think you should be able to watch, but the change of IP address thinks you're not at home, and then therefore you cannot watch the programming that is typically available to you. So these are like live examples of where we can where we have documented and seen impacts to network overlay. Next slide, please. I'm sorry. So having said all that, it would be good if you read the document. We have about almost like 10 sections that document these issues. And the 10th one that we just documented is on content blocking. And again, this is the Fios TV example that I gave you, fits into this mode very well, where you have IP address change, and that basically prohibits you from watching the content that actually you rightfully have the right to watch at home. So, and so this is just a short blurb from the text, but the document provides a little bit more color to this issue. And this might also affect, it talks about the primary URL, which is what I talked about. This could be an impact where your secondary URL, which might be fetching an ad, and company that's paying ad for the service, et cetera, it may not be able to deliver their ads. So that adds to the problem. And I've just given a quick snapshot from the table of content, and you can see these are the types of policy changes that we have enumerated in the document. So all of that is listed here. What really would be good is if we can get folks to review it. The document is simple, and I think it makes an easy reading. But if you review it and you find it's not an easy reading, then that would be a nice comment to have. Because as an author, you always think, oh, this document is so very well written and so easy to follow. But maybe when you read it, you'll say, no, I didn't really follow what you have. So review that just for the context, as well as for the types of issues we have identified. So feedback is important. And next slide, please. And how might you give feedback? There's an easy form that you can even fill out. There's a survey out there that we actually recently circulated around the members of Streaming Video Technology Alliance, which is an industry consortium. Glenn's actually going to talk about it, so you'll learn more about it. But even if you don't need to know about SVTA, if you this link is available on the document. So if you click on it, it's a simple Google form that you can fill out any operational impacts that you are aware of. So you can do that. Or you can even access the GitHub and go directly at and submit a PR.
One important point to note, we are not going to name names or single anybody out. We're looking for input, but we're not going to go, hey, it's that, that guy ratted on that service provider. We're not going to do that.
Thank you, Glenn. Yes. So feel free to submit it if you like to submit through the form, or GitHub is there, or our mops at ietf.org is a good list to respond your comments to. Next slide, please. Plans for moving forward. So between IETF 122, Glenn had put together the slide at IETF 122, so I think which is very helpful to lay out the plans. So between 122 and 123, kind of that's where we are. We took some action items at 122, and we have, I think, completed those at the present time. But definitely want to see if we can get more reviews and feedback. And then I'm going to leave it up to the chairs to decide how they see a path forward.
So that's a cue for further discussion, or at least commitments to read through the document and share comments. At current course and speed, I think we've had some comments back on the document. I think it's a pretty valuable work product from the group. But rather than having the document go forward because nobody's commenting on it, it would be nice to make sure that people are reading it and sending positive support for it to the mailing list. So in addition to interacting with it through the GitHub, please, and through the SVTA survey, please do read the document, share any thoughts. If it's in shape, we can have it go to working group last call in the time frame of the next IETF meeting. If there's more work to be done, um, since I'm not one of the editors, I can say this. If there's more work to be done, we're happy to keep working on it. But it would be good to know which direction we should go. So with that, any comments or questions? I'm not seeing anybody in the queue.
So while we wait, one quick thing I will add is that this document is really enumerating problem statements, and we are hoping that we can come up with the next set of draft. Once this is, of course, approved, that we put together some solution to the problems. So I'll just go back to Leslie and see if there are any other questions and comments, feedback.
Okay, not hearing any comments or questions. I'm going to again encourage people to take it to the mailing list, read it at your leisure, and send comments. Thank you. So next up, we have.
Thank you.
Thank you. Thank you, Sanjay and Glenn. Next up, we have an attempt to play with the clicker again, and Glenn.
Do I get a clicker?
I'll pass you the clicker in a second.
I have all the power now. Okay. I assume the deck will come up eventually.
Dum, 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 dum.
All right. Hi, I'm Glenn Dean. I'm from Comcast NBC Universal. One of the things I regularly do if you come to these the MOPS sessions is I give an update. Part of MOPS mission is to connect professional media and other media activities back into the IETF. And as I come to every IETF meeting, either I give it or Sanjay gives an update of what's going on in the SVTA. And then we typically go back and we tell the SVTA what's going on in the IETF, with the idea that the two groups keep in sync to some degree and that there's cross collaboration. A great example of that cross collaboration is some of the work that's done in CDNI that connects back to open caching work at SVTA. And the network overlays draft started originally as a problem statement identified by SVTA members in their delivery platforms. So the relationship is working pretty well, and we're going to try to keep it alive. So I come in here, I give this update every meeting. Let's see if the clicker works.
Pot a clicker. No.
Next slide, please.
All right. Kyle, if you want to take over the control.
Okay.
Okay.
Is this the first slide or the second slide? I can't tell anymore. So what is the SVTA? The SVTA is a bunch of, it's a member organization that works on video problems. This is a list of our working groups. For those who follow this world, -IF also merged in with the SVTA about a year ago. And so now if you hear about -IF stuff, that is SVTA. If you hear about SVTA, that's part of the -IF. We're all one big happy family. We work on encoding and packaging. We have a new Edge working group that's spun up that's working on how do you host caches at the Edge, how do you feed them, and how do you do delivery in a hosted environment, and how do you deal with things like security issues that come up with that world, which is always thorny but important. So we have a wide range of stuff. I actually over there chair the networking and transport group. You can imagine how that connects to the IETF. We do a little bit of networking and transport here. We do more over there. I'll get more onto some of the work we've done there in a minute. Next slide, please. So one of the things we just concluded in this very hotel this past week, the SVTA co-located ahead of the SVTA or the IETF here in this hotel. We came to Madrid and we did a 3-day member meeting, and we had an open conference called Segments that was held on Friday, which was a really great stuff. And in fact, we've got some material that was presented in Segments by Mike English, who's going to present to you in a few minutes and talk to you about that stuff. So again, building that cross intersection. Why am I showing you what happened last week? Next slide, please. Because we covered a lot of material, I think, which is relevant to the IETF. This is the agenda stuff there. In fact, there you see Mike English listed in the very bottom, media Media over quick in practice. So there's a direct connection. We had Ali Bagan, who's also very active in the ITF. I don't see him in the room today, though. I know he's around. Also gave a talk about mock. So there is cross collaboration going on here with the hope that professional video has a path to contribute to the ITF work and make the ITF even better than it already is. Next slide, please. Oh, and here we had so many talks on Friday. It took 2 slides, so you can see the list of that. We also talked about CAT tokens, which, if you remember, if you were around, we did a talk here in MOPS on CAT tokens by Will Law at a previous MOPS. So interconnection. Next slide, please.
Would you like to entertain Sanjay's?
Oh, I'm sorry, I didn't see Sanjay there.
Sorry, I didn't click
Did he
on.
enter the queue properly?
I didn't. Yeah, I left my phone away. I think one of the cool thing that, besides the list that you have, one of the presentation was on greening the streaming.
It's in there somewhere.
It's hopefully since probably is there. I didn't.
I think it was on the first page, the first list, because it was.
And yeah, and that so there's a common effort going on also on IETF, and the presenter, I don't have his name right now, but he's also here in the meeting.
Can
at
you
the
go back
IETF.
one slide, please, Kyle? Where is it? Oh, no, you went too many slides back. There we go. Green streaming should be in there somewhere. He did present on it.
Right. So I just wanted to just call out that slide. That presentation was very useful for the SPTA members, and also I see that that work also being done here. So some common threads.
Yeah. Yes. Yeah. A lot of common intersection. Okay. Go ahead 2 slides now, please, Kyle. One more. Perfect. So why did I show you what happened last week? It's going to happen again in Montreal. So there will be another, if you're a member of the SVTA, and a lot of people in the room, your companies are members of the SVTA, come to the member meeting, hang out. You get to stay in Montreal for an extra week, which is pretty awesome because it's a great town, great food, great place to be. So we're going to do the member meeting there. And then on Friday before the SVTA, we have another segments conference. So all that agenda you saw there, come, you'll see more agenda. Even better, if you want to talk about something, we're accepting new talks. You can throw your talk in there and you can come and talk about whatever your topic is. It has to be related to sort of video something, but we're pretty broad in what we'll accept because we like video. And that'll be on the Friday before the SVTA meeting. And you can find out more.
ATF.
Sorry. Yeah. You can find out more on the svta.org website, or if you just Google Segments Montreal, it'll come up. Okay, next slide, please. I wanted to bring up something that's related to the work, sort of relevant to the IETF, got that one right, is Quick. We have been doing a long-running Quick POC where we've been evaluating it and understanding it. So we constructed a common test environment so that people doing video have a reference test environment they can replicate in their own environment. But we're also publishing as we go along. There was a document published back in January with intermediate results about the Quick's performance compared to HTTP2 and HTTP1 for the same environment. And there's another update in the works. It's going to be coming out. It didn't come out in time for this meeting, but it's being sent over for publication at the SVTA, and we'll get another document number and we'll pop up on this website, and I'll come and talk to you about it in Montreal. But I wanted to make you aware of that's been going on, and it's something we're exploring, and we're starting to now talk about what should we do around mock and a similar evaluation and a study of the landscape. So next slide, please. So other work that's really relevant to the IETF. Back a number of years ago, one of the key areas identified by the SVTA membership. Oh, sorry, Eric. Did you want to make a comment on the last slide?
Basically, Eric Ving, on the previous slide,
Yes.
previous work, do you intend to present this at the IETF as well?
We have been looking for the right opportunity to present it, yes.
Perfect, thank you.
This is an old document that the SVTA produced a number of years ago, but it's relevant because there is an IAB workshop on Geo that is coming up, that's being scheduled. And they're going to talk about this week, but I wanted to highlight the SVTA is involved in helping with that workshop. There is this older document which was published as a JSON schema
for operators to be able to update IPv6, and it really also works for IPv4 addresses so that we could have proper geo information. And it was done in conjunction with my working group at the SVTA, and it had a number of the geodata companies involved in its preparation. So it's something to pay attention to in preparation for next slide, please. The IAB workshop, IP Geo. So if you are interested in this topic space, consider submitting a paper and by the deadline. It's going to be held virtual, so you don't have to travel for this one. It's going to be, I think it's December is the timeline we're going to have. Yeah, in fact, 3 days of virtual workshops targeted for the week of December 1 will be held. We're going to talk about how do you do updates, how the workflows, all these various topics that are listed there. It's a very important topic space. As Sanjay pointed out, with the network overlays, one of the problems we sometimes run into is inadvertent blocking of people's access to content. That is sometimes driven by inaccurate geolocation information, because most professional content has some form of geo shaping around access to it, either due to license restrictions or sometimes legal restrictions imposed by various parties. And so getting this right is very important so you can always watch what you want to watch. So come join the workshop, please. Next slide. So if you want to get in touch with us, there's my email address, there's Sanjay's email address, there is the URL for Segments 2025 in Montreal. And if you want to know more about us, that's the svta.org. And we also have a lot of open source code we provide. If you go to labs.svta.org, you can find a bunch of open source packages we release that support the various SVTA specifications and intersect with a lot of stuff like open caching and CDNI. So that's SVTA. If you have any questions, track us down. We'll be happy to answer them. And I'll see you in Montreal to
Yeah,
talk about this.
I think one person is trying to get in the queue.
Oh.
Yes.
Hi, Glenn. Very interesting. So regarding the interim results on Quick versus TCP performance, is there a headline message as to what did it find?
Yes. The headline is, it's no better and no worse for basic delivery of streamed video as we do it today. With one caveat, we have found, and other people have noticed as well, is that because Quick does stuff in user space, there is an additional impact at times from a CPU perspective, because as you transition from kernel to user space, you do pay a penalty for things being copied and that transition flip. And so what we have detected is that when we ramp up the number of concurrent sessions, that the CPU utilization by the Quick stuff is less efficient than the TCP-based HTTP 1 and 2 used in other circumstances. So that's sort of the big headline. Overall, from a user standpoint, there's no real penalty, but there's also no real benefit. So the bottom line is, if you want to do it, go ahead and do it. If you want to enable Quick, go ahead. You're not going to suffer from a user perspective, but you might have to scale up your servers and not be able to serve as many sessions from them compared to an HTTP 2 or 1 delivery. I keep going back to 1 because we still have a lot of video that's delivered on 1. So I don't know if this will be true from Mach. We'll have to see. Mach has a similar Quick base, and so there might be that same CPU penalty for that transition. But I will speak up and also nice things about Quick, and that is, the benefit you get from there is you can do pluggable replacement congestion control algorithms that you can't do in other circumstances. So you do get benefit for that CPU costs.
Yeah, cool. Thank you. I look forward to seeing the details if you can share those.
By the way, that thing's fully available. You just go there. Oh, one change I should make. We received feedback from people that said, "Oh, your stuff you guys write at the SVTA is free, but you make me go through an in-basket and all this kind of junk to get it." That's going away. You're going to be able to directly link to a document and just use the SVTA number on the URL, and you'll be able to get to it, and all the other versions that goes along with it. So we made a modification, and I would like to say it's already rolled out. I think it's already rolled out on the website, or it's about to be like in the next week. It's one of the two.
Okay. No, that'll be great. Thank you.
Great.
Okay. Anything in the queue virtually?
Not seeing anybody else in the queue.
Okay. Thanks.
Well, thank you very much, Glenn. And thank you, everyone. And now we will have a remote presentation from Steve Appleby, who I believe is here to talk about BT's deployment. Great. BT's deployment of multicast assisted unicast delivery mod. Take it away, Steve.
Steve, do you want to control the slides or do you want me to control them?
Can you control them, Kyle? Is that okay? Otherwise, it'll
Sure.
be 5 minutes handing over, I think. Otherwise. Great. Okay, so I'm Steve Appleby from BT, and I head one of the research teams at BT Labs in East Anglia. So can we go to the next slide, please? So this is the problem. The problem is these spiky bits on these graphs of bits going through our network. And I think from memory, it started really with particularly Amazon Prime when they got some of the premium sports rights. And we were seeing peaks that were 20, 30% of our network throughput from single events. And the peaks are quite unpredictable in size as well, because they depend on how particular tournaments unfold. So it's really difficult to do capacity planning around these peaks. In the UK particularly, there's been a lot of discussion about terrestrial broadcast switch off. And if we get terrestrial broadcast switch off, then increasingly broadband will be the only way of delivering a lot of sporting content. So we really like an efficient way to deal with those peaks, and a way which is relatively insensitive to the sizes of the peaks. So that's the problem. Can we go to the next slide, please? So we think on the broadband network, multicast is probably at the core of the solution, because that scales in a similar way to broadcast for us. And the approach that we've taken with Maude is a type of multicast ABR system. Other multicast ABR systems are available. And the particular take that we've taken is that it's designed for other people's content. Most multicast ABR systems to date, I would suggest, are designed for network operators' own content services. We've been trying to think, well, how would we adjust multicast ABR to work with OTT services? So how would just ordinary broadcasters wanting to use their catch-up players for live content, how would we make Maude work? How would we make multicast ABR work with those types of those situations? We think we try to do it by disrupting the normal content delivery chain as little as possible. So I guess starting perhaps towards the right-hand side of this, the first requirement is that the player applications cannot be touched. We can't go to a broadcaster and say, could you modify your application to work with our particular technology as a particular telco? That's probably not going to go very far. And most of the broadcasters that we've spoken to have made it clear that they'd be very, very reluctant to do that. So don't touch the app is thing number one. It's actually not that difficult to achieve. It just requires a bit of thought through the way that the request routing works initially, so that we don't have to have a discovery phase where we discover the presence of the multicast ABR system. We just need to avoid that at the application layer. We've thought about it integrating with a CDN primarily, rather than taking its stream input from origin. So that's the yellow box here. Because CDNs are already in the picture, and because as a telco we integrate with CDNs currently, we tend not to integrate with broadcasters directly. So we've taken it through a CDN. That doesn't preclude us going straight back to an origin server if we wished to, but we try to think what were the particular requirements that we might have dealing with the CDN. And so what we do is essentially we just take a stream from the CDN, we replicate it using multicast off to our home gateways, and the home gateway converts it back from multicast to unicast such that it goes through to the end devices, and the end devices are none the wiser that anything in the middle that's all strange has happened. And we built a prototype of this in research, and we've tried it out with a number of devices. We've been pretty successful, I think. The most devices we've tried it on so far, it's worked without modification. The only hitch we found sometimes is the way the DNS works on some devices. We've needed to play some tricks with that, but mostly it just works, and the device just plays the content as it's supposed to. So next slide, please. Can we go to the next slide? Thank you. So not modifying the player was one thing, but the other thing to integrate with the CDN is the visibility and control of the stream. So normally with multicast, it's a sort of fire and forget technology. You put your packet into multicast, you fire it off, and it either gets there or it doesn't. It's not much use for a CDN provider to deliver content that way, I would suggest. They really need to see what's going on and have better control over what's going on. So the trick that we do in Mold, which is a little bit complicated, is that when we actually take the request for a video segment right the way through from the application through to the CDN as normal, the first one of those to pass all the way through for a particular segment is passed through from our root proxy, as you call it, the thing that sits at the root of the multicast tree to do the unicast to multicast conversion. That passes it through as a GET request to the CDN, and you just get a normal response. The unusual thing that does at that point is it separates out the header from the response from the payload of the response. And the header goes up back over unicast to the edge proxy. That's the thing that sits in the residential gateway and does the conversion from multicast back to unicast. So the head comes back to that. The payload is put on multicast. That also goes back to that edge proxy. They're combined, and the full response is then returned to the player, and the player is none the wiser that anything has happened. So far, this is not very interesting. We find a really complicated way of doing exactly what we do currently. It gets more interesting with the second and subsequent requests for the same video segment, in which case the root proxy actually converts them into a head request, so the CDN doesn't need to return the payload, but then that head request, which is possibly unique to that particular request, comes back from the CDN to the root proxy and is just passed over unicast to the edge proxy that request came through. That's already had the payload by multicast, and so the two are combined and returned to the player. What this means is that all requests are seen by the CDN, so they know how many people are requesting particular segments, how many clients are, and they have a degree of control. So if they want to do token-based access controls, for instance, they can still do that from the CDN. They can say who can and can't watch, can't receive particular streams. We just talked about geo restrictions on content. They can do that too if they wish, although that's probably less of an issue with multicast. And so we've split the headers from the payloads in this way. So all the session-specific, all the request-specific information still gets through, because typically that's in the header, but all the common payload gets through by multicast. I guess an interesting side effect of this is that the proxy is synchronized. That is, the leading edge proxy, the one with the first request, is actually synchronous with the root proxy, which means we tend to avoid certain race conditions which can occur in normal multicast ABR. Normal multicast ABR would have effectively a fake client requesting content at the root proxy, and you wouldn't have this right to left path of the requests. They run asynchronously, and you can get race conditions in that, and so you have to usually play tricks with the timing of that. We don't get those race conditions here because it's synchronous. Okay, next slide, please. So we built it in research, but we're now having it built as a product. So we've gone to a company called Broadpeak, who have a multicast ABR product already on the market, and they are modifying their multicast ABR product to work the way that our research system works. And we've been doing a trial on this. Various things with the trial. We've got our own TV service, the BT TV service, is delivered both to a sort of traditional set-top box, but it's also delivered to the Apple TV box with a service provider app running on that. We're trying it with particularly the Apple service at the moment, because Apple is expecting pure unicast. We've also got some Raspberry Pis which run, and they're quite handy for running trials, because we have scripted clients on them that can make requests at particular times, can do all sorts of behaviors that we can script in advance for the testing. Whereas getting users to do things is not so easy, real users. We're working with Quilt as the CDN provider. We have worked with Edgio, but unfortunately Edgio are not available anymore. But we've had no issues integrating with either of those CDNs so far. Currently running with BBC Two primarily, but we have these other channels on the servers that we could put through if we wish to, but at the moment it's just BBC Two. And next slide, please. And we've got some initial results on the bandwidth saving. The whole point of this is to save bandwidth. The approach that we've taken is that there are various algorithms that run in the edge proxy, particularly the proxy that sits on the home gateway. And this is quite cautious as to whether it uses multicast or not. So when trying to switch a unicast stream onto multicast, there's potentially quality issues if there's a lot of demand on the access line at the time of the switching. So the algorithms that run in that home gateway that try to detect those situations, we've set them to very cautious to start with to preserve quality rather than save bandwidth. And what we're doing in the experiments, in the trials, is tuning the parameters of that to see how cautious we need to be or how adventurous we can in terms of saving bandwidth and preserving quality. So next slide, please. And we're doing some more research, so that's not the end of the story. There's quite a list of things that we would like to add as either features or particular edge cases that develop where the system may not work so well. Low latency is one that we are addressing. We'd like to take some of the low latency techniques, the low latency dash, low latency HLS. The thing that we are doing, which is a little bit different here, and I'll just touch on it, is we just had the discussion on QUIC. We are taking advantage of the fact that because QUIC's congestion logic runs in user space, we are linking it with the media a little bit to control the way that the media is delivered at low latency, because many of you here will know that one of the issues with low latency streaming is estimating the throughput accurately, because if you're delivering very small segments and also your transport protocol is responding to congestion, you can't get a good handle on how much spare bandwidth there is. But if we can combine that with the server-side logic from the congestion algorithm state within QUIC, we've found that we can get a much more stable performance out of that. So we're trying to combine that unicast type technology with MAUD to give us an end-to-end low latency, scalable low latency solution. The other thing we're looking at as well is personalized adverts. We're working with a partner here to get some signaling of what ads are coming up in the next ad break, and to look at various means for delivering those efficiently so that when we get to the ad break, we don't all drop back onto unicast and get the unicast ads. I mean, the ads work fine with the system as it is, in the sense that the user views the ad they're meant to view, but it's not very efficient. And the two efficiency mechanisms we can bring to play here are we can either preemptively deliver the advert to the home gateway, or we can make use of multiple multicast groups for the same channel and decide which ads are going on which multicast group and which edge proxy should subscribe to which multicast group. So we're investigating both of those efficiency tools in the current research. And I think that's it. Yep.
Great.
Thank you.
Thank you very much. Any questions from the group? I'm not seeing any, but I'll give people half a heartbeat. All right, so we've got one. All right, great. The queue is filling up.
Alan Frindell, Meta. Thank you for this work. It's really interesting. I'm curious how the security works in the edge proxy. Like, does it have the certs and keys for the domains that the client is accessing?
Yeah. So good question. So it works with TLS, so it does provide a proper certificate from the edge proxy. But what happens as part of the request routing at the moment? So we've got different options for this, but the way that we're working with the content partner we're currently using is that they actually modify their CDN selector to recognize MAUD as a CDN. So they actually they request the content from maud.bt.com, and we then provide a certificate for maud.bt.com. So it's our certificate for our domain that we are providing from there, and they treat us as a CDN. So we are just another CDN to them.
Okay. I need to think about it more. Thank you.
Okay.
Hi, Eric Ving. Interesting presentation for sure. Just two questions. How many peak multicast group did you have? Is it 5, 100 multicast?
Oh no, that's an interesting question. So it depends partly on how dynamic we make the system, because you can imagine those peaks are, most of the peaks we see are driven by one stream, right? So you could eliminate a lot of those peaks by just having one multicast group. We don't need a multicast group for each profile because the profiles are very unevenly distributed. The top profile tends to be, by far more common than the others. They could be delivered by unicast without too much of a problem. So we can get a lot of benefit from just one. We will have more than one. Some of them we'll probably have statically configured for particular popular channels that are there all the time. But I'm thinking it's a much smaller number than you would have for a normal IPTV service. But I don't know what it is, but yeah.
And during your trial, were you using IPv4 or IPv6 out of curiosity?
No, that's a good question. So we were using IPv4. Yes, I know, sorry, apologies. But I don't think it matters to us very much. I think the only impact I can think of on this system is that edge proxy, because initially I didn't explain this, but initially it starts out in pure unicast mode where it's just proxying the content in unicast. You must use the same version of IP on the client, on the LAN side as you do on the WAN side, so that you preserve the IP address as you switch into Maude. But I think that's the only difference it makes to Maude, because Maude really operates at the HTTP layer rather than IP.
Okay, thanks.
Sandy Zhang, ZTE. I'd like to know what's the distribution tree was built. Because when you want to transfer the multicast flow, you must make some multicast tree at first, right? So I'd like to know if you will make the tree in advance.
So I think I've understood the question. So we're using the same multicast that we would use for our IPTV system already. So the replication points for the multicast are virtually every layer 2 component in the network and layer 3 component are capable of replication. So it goes right the way out to the cabinets that sit in the street. That's and even in the home, and the gateway itself could replicate packets if necessary. So it's very efficient, I think.
Okay, and the second question is that I think the edge device is very important here, because you must collect all the requests from the users, right, and transfer it into multicast. Yeah. And I'd like to know what the device it is. It's just a software, or it's a hardware. Yeah.
I know, so it's just software that runs on our. So I haven't put it in much detail here, but our hub, we have our own operating system on the hub that's built on OpenWRT, and it's just a single container that runs on top of that OpenWRT that does all the software there. That does, and you're saying also sharing with the CDN. One thing that I didn't put here is we have that element of control and visibility from the CDN, but separately, we have sharing of the full logs in that edge proxy with the CDN as well, to keep the CDN fully informed of every transaction that's happened from that proxy too. So I don't know if I quite asked your question. So maybe if I haven't, just maybe refocus my answer. You clarify that a little bit.
Okay, thank you.
Is that it? Okay.
And we are running a little over time, and I've locked the queue, so do go ahead, the last 2 questions, and if we can keep the question answers.
And I'm very happy to take questions separately after this by email or whatever.
Great, thanks. But Lenny?
Sure. Lenny Giuliano, HPE Juniper. The edge proxy, is it always on your network, or do you have aspirations for it to be elsewhere, where you could do something like TreeDN and that edge proxy could sit anywhere on the planet?
No, TreeDN's come a few times in our discussions. Yep. So the way that we're picturing at the moment is it will be a product for use on a network by each ISP. They can procure the things separately for their own gateways, etc., and run that. So we haven't currently got a plan to go to TreeDN. I will go back and look at TreeDN, because I'm being encouraged from a number of sources that we should look at that, inclusion of that in some form or other. So I haven't yet looked at it properly. Did a little while ago, but I haven't done recently. I think a few years ago now, when I think it's based on Cisco AMT, wasn't it? No, we did look at AMT some time back, but it sort of works the wrong way around for us, AMT particularly, because it encapsulates it sort of assumes that the world is basically multicast with gaps in it, and you want to connect the multicast islands. We've sort of assumed that the world is basically unicast, and we're trying to connect the unicast with by inserting a bit of multicast, and we tunnel the unicast over multicast. So the tunneling is sort of the other way around with the way that we're doing it. But I will go back. This is a further prompt for me to go back and reconsider TreeDN. Thank you.
And Steve, for your benefit, Lenny is Mr. TreeDN, so you may want to.
Okay. Thank you.
Hello, Jordi Sensano, Meta. One quick question, because I'm a bit confused. So based on this slide that you have right now, it says that add media segments delivered by multicast to the set-top box. But in your other slides, it seems that the last mile is unicast. Which one is?
Oh, yeah, sorry. So I'm sorry if the slides were confusing. So it's always unicast in the home. The LAN is always unicast. There's no multicast in the home on this. The set-top box that we currently have is just a normal IPTV set-top box, but does take some unicast services. So some of the channels are delivered to that by multicast. But I will go back and correct the slide if it was misleading there and showed multicast going to the set-top box. Ours always just goes to the residential gateway and doesn't go any further than that in Maud. It's always unicast over the home.
Okay, and then, sorry for the question, but if you only apply multicast inside your network, and I assume your network is good enough, so not a lot of, because it's internal, not a lot of retries, packet loss, etc. And I also assume that you have a good request coalescing. What problem are you solving using unicast over multicast?
Well, the fact that you can't, I mean, the content providers normally deliver to unicast-based apps, right? They can't get their content into multicast. They can't operate their ABR algorithms, for example, to deal with Wi-Fi congestion in the home without that conversion back to unicast for delivery within the home. So in terms of pure scalability, you're right. The scalability aspect just comes from multicast. So we're not achieving scalability here. What we're doing is providing a mechanism to get more content into the existing multicast network. Because there's no way, for example, BBC with iPlayer, they could not really engineer that to work with multicast.
Okay, I need to think about it, but thank you.
Great. So thank you, Steve, for the presentation.
You're very welcome.
And thank you, everyone, for your comments and questions and follow-up. And now we will move to Mike English, who's going to tell us about his deployment experiences with Mock. And you could take 15 minutes.
Okay. So this is a modified version of a presentation that I gave on Friday at the SVTA. I sat down to make it shorter, and I ended up with more slides. So we're going to put Kyle to the test on quickly shuffling through these slides. So I'm Mike English. I'm an engineer at Cloudflare. Here's what we're going to talk about. Okay, go ahead. Why Mock? Why now? My experience with implementation, kind of the ecosystem as a whole, and what the future looks like. Next slide. Next slide. So the current state of the world, you may know there's kind of two large families of doing video media. There's kind of the HTTP-based world that's used for video on demand and live streaming content. And then there's kind of the RTC world, WebRTC, Zoom, etc. So one of the goals of Mock is to kind of achieve low latency at scale. And it gives us an opportunity to revisit some of the fundamentals and hopefully factor things in a way that is useful. Next slide, please. Here's another way of looking at kind of the bifurcation that exists today. Some of the HTTP-based technologies are good at certain latencies, and RTC technologies are good at very low latencies, tuned for these latencies typically. And there's a gap in the middle that isn't being served particularly well, and we think Media over Quick can help there. So that's kind of our initial target. Next slide, please. A lot of people ask, why not just use H3? Glenn was kind of talking about this. You can use H3, but you don't necessarily see much advantage if you're using kind of existing HLS dash as is and just switching from H1 or H2 to H3. And the reason for that is H3 is not inherently media aware. So you want to be able to map more of the structure of your media, kind of your dependency structure, to the transport layer so that you can take better advantage of multiplexing. And that's kind of where Mach is. It's that mapping. Next slide, please. Here's where Mach fits in the protocol stack. You can see kind of like WebRTC and HLS and Dash on the left side. And Media over Quick kind of sits on top of Quick and on top of Web Transport. The spec currently supports both options as the underlying transport mechanism. So you get this funny shape. Next slide, please. Media over Quick is also looking to replace both the ingest side and the distribution side. Replacing things like RTMP as well as HLS and Dash, replacing things like WebRTC. And we hope that part of the design and the way that we've decoupled the media layer from the transport layer should allow for better economies of scale, because greater diversity of use cases can use the underlying Mach transport protocol for fan out. We'll see. Next slide, please. This is a visualization of kind of the layering and the decoupling. So Media over Quick transport deals with kind of generic ideas like objects and tracks. And there's another layer on top that's kind of the streaming format layer. And that is where you actually know what kind of codec you have and more specific things about your media. So this is different than, say, with like a WebRTC SFU, where there's tighter coupling between some of the media properties and the data that's being relayed by the SFU. Next slide, please. Okay, so my experience using this. Next slide. Cloudflare has a network. It's all over the world. It's like 333 cities that we have a presence in. Next slide, please. It's an Anycast network, which is interesting. It makes it interesting to deploy things to that. So we effectively deploy most every service everywhere, which means when I started at Cloudflare in March. In April, I deployed software, and it was immediately, next slide, please, everywhere. I've had some Mach relays deployed. However, besides being potentially the largest ever Mach relay deployment, it's also the most useless Mach relay deployment because they're addressed via Anycast, and they're not aware of each other as of yet. So you can reach any one of them, but if you publish into one, you can't egress that from another relay just yet. Next slide, please. I have a release queued up to roll out today that wires this stuff up. Next slide, please. So we based our implementation on MachRS, which is in Rust. One of the big realizations in taking this and turning it into more of a production service is that you actually want to integrate with quite a few things that are like internal and specific to your particular network, your particular context that you're deploying into. And that's going to require some significant refactoring. So if it looks like work has stalled on MachRS, that's because my attention has been on kind of the other side of that picture. And I've picked up MachRS again for the hackathon, and I'm working on bringing it from draft 7 to draft 12. So hopefully this week you'll see some updates there, and then I can port those into our internal fork. Next slide, please. The spec changes a lot. That can be a lot of work. You have to balance that with the system integration piece, like I was saying. Prior experience from working on implementation for a media server is that the media complexity is something, especially on the receiver side, if you're using Media over Quick and you have, your media is all like multiplexed into a bunch of different pieces. You have to stitch it back together again, and that can be complicated. But that's also something that you can opt into, like how much of that you want to deal with, because you could decide as a publisher, if you control both ends, the original publisher and the end subscriber, you could decide I would like my tracks to be relatively simple to start, and then I can add these features as they become useful to me. Next slide, please. Practical trade-offs. We're not doing everything. We're not even doing everything that's in the version of the spec that we've implemented. It's on the roadmap, but we're prioritizing kind of the key features, which means subscribe. We're not dealing with the past. We're not dealing with fetch yet. And like I said, we've kind of focused on rolling something out that works end to end. And now we're coming back around to look at, okay, let's catch up with the latest draft. Next slide, please. One of the things that's challenging in working with Quick and Web Transport is things are a little bit more opaque because of encryption. Even in a local environment, it can be challenging, especially if you need to take advantage of these properties to introspect things. QLog can help, and we have now a draft that Lucas proposed for some extensions to QLog to expose some more of the media real quick stuff in that context, which is helpful too. Next slide, please. Next slide. Mock encoders. There are some encoders commercially available. There's also some open source demos. Next slide. On the playback side, basically JavaScript players is the way forward. You can read the rest of the slide if you want more details. Next slide, please. Mock relays, we're working on a relay network. In the future, we might integrate with some existing media services that we have, but right now we're focusing just on the mock piece as a standalone thing. Next slide, please. There are a bunch of other open source implementations now, and you can find a bunch of them listed in the wiki. So go look at that if you're interested in seeing more code. Next slide. Next slide. We would like to measure things. Very curious to hear what people want us to measure. We have a big network, so it could be fun. Next slide. It would be great to see more people kind of implementing things, validating things, taking that feedback back into the spec, starting to look at that next layer, the streaming format layer, with more attention. And the big thing is like web transport. Media over Quick kind of depends on that for all the use cases where a browser is involved. And it would be great if that were more done and robust and available. So that's a big ask. Yep. So there's some IETF working groups. You can attend these meetings, read these drafts. Next slide. And if you have comments, questions, you can take them to the Media Over Quick list. Or if you have questions about my specific experience or work at Cloudflare, you can email me.
Great.
Thank you.
Thank you so much, Mike. And we have time for one or two questions. There's one in queue. If anybody else has a question, queue quickly, please.
Okay, yeah, super quick question. Jordi from Meta. Thanks, Mike. Excellent summary about MOQ. Just you mentioned that web browsers are not mature or not very stable yet in web transport. I totally agree, and I think there are people here working on browsers, so please, that would be great. I would also add web codecs. Same, because if you want to build your player in the browser, web codec implementations in Firefox, Safari, and Chrome. So basically, you run something on Chrome, it does not work on any of the other two. So please, let's stabilize web transport and also web codecs. That will help Mock a lot. Thank you.
Great.
Thanks.
All right, not seeing anyone else in queue. Thank you very much, Mike, and well done keeping all those slides in 15 minutes. I will say thank you very much to Alan Frindell, our note taker, and thank you everyone for coming out to participate in this week's MOPS meeting. And with that, thank you and see you in Montreal. figured out reasonable lunch things?
Super desperate.